मिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम नहमदुहु व नुसल्ली अला रसूलिहिल करीम। Class, yesterday we have discussed the first lecture of sulfonamide. That was the introductory lecture, and we have talked about the sulfonamide, and I have told you that we have selected sulfonamide as a first topic because from this topic we are going to have different types of the concepts, such as concept of prodrug, concept of pH and pK, the concept of antibacterial, bactericidal compounds. We have got different terminologies which are used here, and we are going to define that and then relate it with the SAR of sulfonamides. SAR of sulfonamides tells us that thousands and thousands of compounds which are synthesized or derivatized from the parent compound, that is sulfanilamide. Out of those thousands of derivatives, only few are substituted at different positions, otherwise all the substitution is carried out at nitrogen of the sulfonamide group, or you can say one hydrogen from the SO2NH2 is replaced by different groups, and then we have got the different derivatives. And as I have just told you that we have synthesized thousands and thousands of derivatives, safely we can say that more than 5,000 derivatives are reported, while the number is more than this. And after observing these compounds, we have concluded few things. And when we are discussing SAR, we are saying the structure activity relationship, or here we are using two terms. One is that if we are going to modify the structure, what will be its effect on its activity, and the other point is that what are the sites or where we can substitute, or which sites cannot be touched, cannot be substituted. Here we have seen that the structure for antibacterial sulfonamides at least should have a benzene ring and two functional groups. One is amino and the other one is sulfonamide group. And these two functional groups should be present at para positions or at para to each other, while the other four positions should be unsubstituted. and a free amino group at para position is a prerequisite for antibacterial activity. What does it mean? We have got a very limited site for the modifications. Just I have told you that out of thousands derivatives, only few are those in which the site of substituent is different. Otherwise, in all of these, one H2 from the SO2NH2 is replaced. This structure is of sulfanilamide. Here we have got one aromatic ring and two functional group. One is amino group and the other one is sulfonamide group. They are present opposite to each other, that is, they are at para positions or they have occupied the 1 and 4 position of the benzene ring. I have told you that the minimum essential requirement for the antibacterial activity is that an aromatic ring and the two functional groups at para positions. This molecule satisfy those criteria and hence the sulfanilamide have got the antibacterial activity. And I have told you before that by modification at different positions, I have just told you that modifications at different positions of the aromatic ring or by the substitution or modification of the NH2 or SO2NH2 or the two functional groups, we are going to have thousands of compounds. But this NH2 is prerequisite for the antibacterial activity. While this R is replaced by a number of the compounds. In one of the example, we can see that this compound, that is IPTD, the compound have got the sulfanilamide or sulfonamide structure, an aromatic ring, an amino group, SO2 and H. One H is replaced by this moiety or molecule. This compound was used to treat the typhoid, and in 1940 during treatment it was observed that the death toll is increased to several folds. Hundreds of deaths were reported by the use of this compound to against the typhoid fever. Investigation was carried out and it was found that the compound is inactive. There is nothing wrong with the compound as its activity as an antibacterial compound. But the patients or the persons were died due to hypoglycemic condition. What does it mean? The sugar level of those patients were slowed down or were reduced, or a prolonged hypoglycemic condition, a result in the death of those patients. Then it was found that this compound, which was used as antibacterial compound, also have got the anti-diabetic activity. From here we have got the lead. Initially, the compound was used in which the NH2 was present, but instead of this moiety, it is changed to this one, and the compound is carbutamide, while the by observing that this compound IPTD have got the anti-diabetic effect, new molecules are synthesized. One of the molecule is carbutamide, one of the molecule is carbutamide. In this carbutamide, we have got NH2, still we have got NH2, only the change is at this position. Let's see, the change is at this position. It means carbutamide still have got the antibacterial activity, although the anti-diabetic activity is increased. Then we have got this tolbutamide. Just see in tolbutamide, here instead of NH2 we have got CH3. Here instead of NH2 we have got CH3, and just by changing the NH2, the antibacterial activity is abolished, is finished, and now this tolbutamide is one of the important anti-diabetic compound, is one of the important anti-diabetic compound, or it is one of the derivatives of sulfonylurea. You know why we are saying that sulfonylurea? Here, this up to this we have got the sulfonamide, and then COO NH COO NH. This group is the urea. This group is the urea COO NH. That's why it is termed as the derivative of sulfonyl urea, one of the important antidiabetic compound. In the same way, we have seen that there is another molecule, that is furosemide. In furosemide, we have got the furfuryl group, but here aromatic ring is present, but different substituents at different other position of the benzene ring. What does it mean? It means that just we have said that the other four positions on this aromatic ring should be unsubstituted. Here we have got the substitution at different other positions, and by this we have got a diuretic compound. We have got a number of compounds, a number of class of diuretic compounds which are derived from the parent compound sulfonylamide, that is derived from the parent compound sulfonylamide. We have got thiazides, hydrothiazides, loop diuretics. These are the different classes which have got a number of diuretic compounds, important compounds, and is still in clinical use. So just you can see that by changing the functional group or by substitution at other positions will give the compounds which have got other effect, but all of these compounds have got SO2NH2, as you can see. That's why they are termed as sulfonamide. Toluidamide is almost the same related molecule, only the main change is CH3 with NH2, while in furosemide different other positions of aromatic ring is substituted. Hence we can see that the aromatic ring is important, is essential. One of the amino group at para position should be present at as free amino group, and SO2NH2 from this functional group only one H can be replaced with the retention of the activity, that NH we can see here. The NH, one H is substituted by succinic acid. Here one H is substituted by phthalic acid, or we have got the succinyl salt of sulfathiazole or phthalic salt of sulfathiazole or succinyl sulfathiazole or phthalate sulfathiazole. These compounds can be termed as prodrugs. What is the definition of prodrug? Prodrugs are the compounds which are inactive in vitro but become active in vivo after metabolism in the body or in the living system. Here the same phenomenon is there. This in the body, this molecule is inactive in vitro, but in the body after metabolism, this succinyl or succinic acid will be released, and this NH will be converted into NH2, or a free amino group will be generated that will give the sulfathiazole, that will be the active molecule. That will be the active molecule. In the same way, here, after metabolism, after hydrolysis, the phthalic acid will be formed and NH will be converted into NH2, and we are going to have the free amino group, and again we have got the active molecule, that is sulfathiazole, the active molecule. In the same aspect, this NH2 can be replaced by NO2, and after metabolism, that NO2 will be converted into NH2, and again we are going to have got the free amino group and we have got the active compound. What does it mean? At NH2, few modifications can be possible. Few modifications can be possible. A free amino group at para position is a prerequisite, and can only be modified, replaced in a way that after metabolism a free amino group will be generated, such as succinyl, phthalate, or nitro derivatives. If SO2NH2 is replaced by other groups such as CONH, it reduces the activity, or maybe activity is completely abolished, while by replacing one H from the SO2NH2, we have got highly potent compounds, highly potent sulfonamide compounds, and out of 1,000 derivatives, the compounds which have got the 5 or 6 membered aromatic or heterocyclic molecules have got the increased or highly potent sulfonamide or antibacterial compounds. The different derivatives which are different derivatives which are used clinically or nowadays which are used clinically are the 5 or 6 membered heterocyclic substituted molecule. We are going to discuss those derivatives in the next lecture, inshallah. These derivatives in which we have substituted the 5 or 6 membered heterocyclic molecules which are potent compounds. Why we have selected this 5 or 6 membered heterocyclic ring as a substituent? This point will be discussed inshallah in the next lecture when we are discussing the mode of action, mechanism of action of the compound. It means in the same molecule we have got the same site at which different substituents can provide the highly potent compound as well as the different substituent may give the toxic or highly toxic compounds. Before closing the lecture, just I am advising you to see few definitions. I know that you have got the concept about that, but it is better to revise them. That will give you more help in understanding the next lecture. The terms are antibacterial compound. What is antibacterial compound? Why we are not saying it antibiotic, or whether we can term those compounds as antibiotic. What are bactericidal compound? What are bacteriostatic compounds? What is the role of pH and pKa in the pharmacokinetics of a molecule, or to reduce or increase the toxicity of the molecule? Inshallah, I think you will read it and will get help from that one. Okay, thank you very much. Allah Hafiz.